Okay, 4.6 is the last section in chapter 4 that we're going to do. The topic is polynomial and rational inequalities. We've been there and done that before with quadratic inequalities, so now we're going to see more examples of ones that are not quadratics. So for example, suppose that I want to know where x cubed plus x squared minus 5x plus 3 is less than or equal to 0. The fact that I'm less than or equal to 0 means that automatically I know I'm going to want the negatives in the table that I'm going to make here. And by the way, I will be making a table. Okay, so let me call the expression on the left f of x and set f equal to 0. This won't factor nicely for me. And so, but f of 1 is equal to 0. So x minus 1 is a factor. 1 is in common to the 4 terms, so 1 is going to go outside the division bar in the upper left-hand corner, and 1, 1, negative 5, and 3 are going to go up top. Bring down 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Negative 3 times 1 is negative 3. 3 minus 3 is 0. By the way, it should make sense why we get 0 left over is because we already know that 1 is a 0 of f. Okay? So now what I'm more concerned about is the polynomial that we get to the left of that, which is x squared plus 2x minus 3. Okay? And that's going to factor as x plus 3 times x minus 1. So the factor is x minus 1 times x plus 3 times x minus 1 equals 0, or x equals 1, and x equals negative 3. Now, by the way, I know from the fundamental theorem of algebra that I've got 3 zeros. 1 is the 0 of multiplicity 2. Negative 3 is the 0 of multiplicity 1. So in other words, I got 3 answers here. Okay? But that's going to only split the table into 3 sections for me instead of 4. My things I'd write are interval, number chosen, value of f, and then the conclusion. Negative 3 and 1 are the values that go on the number line. And the intervals will be negative infinity to negative 3, negative 3 to 1, and 1 to infinity. The number that we choose can be any number in this interval. Okay? You got to make sure that you're in the interval, though. Okay? Like let's use negative 4 for the first interval. I need a number less than negative 3. Negative 4 is good. If I plug negative 4 into f, negative 4, f of negative 4 is negative 25. Okay, and that's going to be a negative number. Okay, if I plug in 0, I get 3. That's a positive number. And if I plug in 2, I get 5. 2 cubed is 8, plus 4 is 12, minus 10 is 2, plus 3 is 5. Okay, so I'm positive. Now, I already said early on here that numbers that are less than 0 are negative numbers. The fact I'm including negative 3 means that I'm including the start point, negative 3. So the set of all x such that x is less than or equal to negative 3 would be my answer. Okay, I just circled the first group there. Another problem, suppose that we want to find where x plus 3 times 2 minus x divided by x minus 1 squared greater than 0. Well, x minus 3 times 2 minus x equals 0 means that x is equal to negative 3 and x is equal to 2. Now, whenever you have a quotient, as is the case here, you need to set the numerator equal to 0 and the denominator equal to 0. Okay, so when I set x minus 1 squared equal to 0, that means that x is 1. Okay, now I know right away that I'm going to want the positives from the table. Okay, because I get an expression that's greater than 0. Numbers that are greater than 0 are positive numbers. So on the number line, here I'm at -3, here I'm at 1, and here I'm at 2. Negative infinity to -3, negative infinity to -3 to 1, and 1 to 2, and 2 to infinity are the intervals that I get. I need a number less than -3, so like -4, for example. If x is -4, then I get -6 divided by -5 squared is 25. -6 over 25. If x is, and that's a negative number, of course. And if x is 0, 3 times 2 is 6. Divided by 1 squared is 6. 6 is a positive number. A number between 1 and 2, like 3/2, would be a good number. Means that x is 9, that the value of x is 9. And if x is 3, 3 plus 3 is 6 times, that's -6 divided by 2 squared is 4. 6 over -4 is -3/2. Okay? So we're back on negative again. Now I said early on here that I want the positive columns represented. So the numbers that are producing positive output, positive values of f, are going to be circled. And so the set of all x such that x is between -3 and 2. X cannot be 1 though. Okay, is my answer. So I'm still making a table, although I've got a rational inequality. Okay, and or if I get a polynomial inequality, I'm still making a table there. Okay, the numbers that are in the homework are on right here, page 248. Be sure to look at those for me.